Now I'm going to talk about a couple other things that we can use with trig ratios then we don't know every single piece of information. First of all, notice we have this information here. We know sine is 2/3, and we know that the angle is in quadrant 2. So we know that this angle is all the way over here. But we know something about it. That the point, it goes through the point, and I know this isn't the perfect drawing, that we know that y and r are 2 and 3. So what we need to find is x. So using the Pythagorean theorem, we can find out what the last side is. So x squared plus 4 equals 9. We get x squared equals 5, so x is equal to the square root of 5. So this is equal to the square root of 5, but we have to be careful because this is now a horizontal distance from the origin, so it's a negative distance. So when we talk about sine, we already have that. When we talk about cosine, since it's in quadrant 2, it's negative, so that's negative square root 5 over 3. Tangent, well, if I write this, it's going to be negative, but I'm writing 2 over the square root of 5, so I have to write it as 2 square root 5 over 5. Cosecant is going to be the reciprocal of sine, which is 3/2. Secant is the reciprocal of cosine, which is 3 over the square root of 5, which is 3 square root 5 over 5, and that's negative. Cotangent is going to be the reciprocal of this, but in reality it's going to be negative square root 5 over 2. And there are my 6 ratios. Same idea, different problem. Quadrant 3, I'm going to draw it like this. Cosine, this is negative 3, this is 5. What you're going to find is that y is equal to 4. And then you can write all of your ratios very similarly. It's very nice this way because of the fact that you have whole numbers, not radicals, to work with. But using x squared plus y squared equals r squared, you'd get the exact same thing. You'd get y equals 4. So in the next section I'm going to talk about just dealing with acute angles versus all angles on the coordinate graph.